We are going to solve this question from your additional math textbook. The question says, a sphere with center O and radius 3 center O fits exactly on the sides of an inverted right circular cone of height h. It's an inverted cone. Height h. Base of the radius r, and theta the angle between TP and TB. So r and theta. H is a height. If the volume is V, the question is express V, the volume, in terms of H, height of the cone. Hence, find the value of H for which V is stationary and determine its nature. Okay, so as we know, the volume of a cone is 1/3 area of the base times height. Now we need to express V in terms of H. So what is R in terms of H? We know that the radius of the sphere is 3. Okay. Let us put some letters. T, O, P, A, B, Q, R. Now the problem is to express R in terms of H. From the triangle APT, we see that tangent theta equals R over H. Therefore, if we multiply by H, we get R equals H tangent theta. Now we got H, but we got theta as well. How do we get rid of theta? We need to express theta in terms of R. So we move in the triangle QOT, where tangent theta, which we need, is equal to OQ, which is 3 over QT. Now how am I going to find QT? QT from the same triangle, QT is square root of OT squared, so OT is H minus 3 minus 3 squared. Now because I need, in the volume, I need R squared, and R squared is H squared tangent squared theta, I'm going to find tangent squared theta. So tangent squared theta is 9 over QT squared. H squared minus 6H plus 9 minus 9. So the volume is pi over 3 R squared. Remember R is H squared times tangent squared theta times H. Okay, so from the previous slide, we found that the volume is 3 pi times H cubed over H squared minus 6H. The question asks to find the value of H for which V is stationary. So dV by dH must be 0. What is dV by dH? Of course, we use a quotient rule. 3 pi is a constant. Quotient rule, the derivative of H cubed times H squared minus 6H minus h cubed times the derivative of h squared minus 6h over h squared minus 6h squared, giving me 3 pi times 3h squared brackets h squared minus 6h minus h cubed brackets the derivative of h squared minus 6h, so 2h minus 6 over h squared minus 6h squared. So okay, so this is dv by dh. We can factorize 3 pi h cubed bracket h minus 12 over h squared minus 6h squared. Now in order to determine if it's a maximum or a minimum, we have h dv by dh. For h equals 12, we know that dv by dh is 0, so h is stationary. The tangent of the graph is horizontal. Now before 12, like for example 11.9, I can either plug into my calculator dv by dh for h equals 11.9, or I can think on the graph that the denominator is always positive. It's square. 3 pi h cubed is always positive. So what's the sign of h minus 12? If h is 11.9, this is going to be negative. If h is 12.1, then h minus 12 is going to be positive. So before 12, the graph decreases. It's a negative slope. After 12, it's a positive slope, so the graph increases. Therefore, we have a minimum volume for h equals 12.